Okay, systems with three variables. So we're basically taking what we did last time and just bumping it up a level. So we're making, this is just a little bit harder than it was last time. Okay, it's just way more tedious. It's a lot more, it's a little bit more work. So please, please pay really close attention to this one, okay? So we're dealing with three dimensions now. So we still have our x and we have our y, but we also have a z plane now. Okay, so there's three dimensions here. When the planes all intersect at one point, that's just one solution. So we just have one solution there. If no points lie on the same three planes, that's no solution. And then if they all three intersect at a common line, that's infinite solutions. Okay, so there's three different types of solutions you can get here. You can get just a point, you can get infinite solutions, or you can get no solution. All right? Here's the procedure to follow. You can keep that there if you want to read all that, or you can just pay attention to this one, okay? So keep it there so you can kind of look at it, but let's just start going through this. So the first thing we're always going to do, we have these three equations here. X minus y plus z equals -1. X plus y plus 3z equals that, blah, blah, blah. I'm going to label each equation. So that first equation is just number 1, second equation is number 2, third equation is 3. And I'm going to do these in different colors so that you can differentiate them. Okay, so the first thing I always want you to do is label each of these. Now we need to decide which variable am I going to get rid of. We have to use this by elimination. So I'm going to get rid of my y's because I have a negative y, I have a positive y, and I have a negative y. So those will be really easy to just cancel out. So I'm going to take equations 1 and 2, and I'm going to add those together. And I end up with x plus x is 2x, negative y plus y cancels out, z plus 3z is 4z, and then -1 plus -3 is -4. And I'm going to label that equation number 4. Okay, now I'm going to look at equations 2 and 3, and I'm going to add those together. So I have x plus y plus 3z equals -3, 2x minus y plus 2z equals 0. You add those together, x plus 2x is 3x, y minus y cancels, 3z plus 2z is 5z, and -3 plus 0 is -3. And I'm going to call that equation number 5. Okay, now I have two equations, so equations 4 and 5 with just x's and z's. So I need to look at equation 4 and 5, and I need to solve for one of those variables. So I'm going to do it by elimination, and I'm going to get rid of my z's. And to get rid of those, I'm going to multiply the top equation by -5 and the bottom equation by 4, so that those will become opposites of each other. So you multiply that top equation by -5, bottom equation by 4. And you get -10x minus 20z equals +20, and 12x plus 20z equals -12. Now you add those together. -10x plus 12x is 2x. The 20z's cancel, and 20 minus 12 is 8. Divide by 2, you get x equals 4. Okay, so now I have x. I'm going to go back and plug that into equations 4 or 5 to solve for z. I'm just going to plug it to equation 4. So I have 2 times 4 plus 4z equals -4, which is 8 plus 4z equals -4. Subtract that 8 over. 4z equals -12. Z equals -3. Okay, now I have x and I have z. I'm going to plug those into equations 1, 2, or 3 to solve for y. And I'm just going to plug it into equation 1. So I have 4 minus y plus -3 equals -1. 4 minus 3 is 1, so 1 minus y equals -1. Subtract the 1 over, you get -y equals -2. Divide by -1, you get y equals +2. So I have solved for all three variables. Now I just have to write this as a pair. So that's going to be 4, 2, -3, because you always write it x, y, z. In alphabetical order, x comes first, y, and then z. So that's our final answer there. Okay? Let's look at example number 2. So again, first, I'm going to label my equations. So 1, 2, and 3. Now I need to decide which variable to get rid of. I'm going to get rid of my x's here because I have x, 2x, and 2x. So those will be easy to get rid of if I just multiply that top equation by -2. Okay? So let's look at 1 and 2. I'm getting rid of my x's, so I need to make that top equation -2x. So I'm going to multiply by -2. And that's going to become -2x plus 4y minus 6z equals -24. Now you add those together. The 2x's cancel. 4y minus y is 3y. -6z minus 2z is 8z. -24 plus 5 is -19. And I'm going to call that equation number 4. Now I'm going to go back and I'm going to use equations 2 and 3 because I have to use all 3 equations, so that's why I used 1 and 2. Now I'm going to use 2 and 3. I'm going to multiply the bottom equation by -1 to make that a -2x. So that becomes -2x minus 2y plus z equals -4. Now we add those together. 2x minus 2x cancels. -y minus 2y is -3y. -2z plus z is -z. 5 minus 4 is 1. And that's number 5. So I'm going to label that as 5. Now I'm going to look at 4 and 5 and solve for one of those variables. Here it looks like we have 3y and -3y. Those will cancel, so let's just get rid of our y's. Let's add those together. 3y minus 3y is gone. -8z minus z is -9z. -19 plus 1 is -18. Divide by -9 and you get z equals 2. Now I'm going to plug z equals 2 into equations 4 or 5. It doesn't matter which one, just one of them. So I'm going to plug into equation 5. So I have -3y minus 2 equals 1. Add the 2 over, you get -3y equals 3. Divide by -3, you get y equals -1. Golden. Okay, now we have our z, we have our y. Let's plug that into equations 1, 2, or 3 to get our x. And I'll just plug it into equation 1. So I have x minus 2 times -1 plus 3 times 2 equals 12, which is x plus 2 plus 6 equals 12, which is x plus 8 equals 12. Subtract the 8, you get x equals 4. Then the last thing is to just write this as an ordered pair. So that would be 4, -1, 2. And that's your final answer there. Okay. I'm not going to go through this last example. If you got confused, go back and rewatch that. For that last example, I want you to try it. You should get 2, 1, -4 for your answer. Okay? Please make sure to take the quiz, and remember, this is the last video for this unit, so we will be testing right before Thanksgiving break. So just make sure you're aware of that, okay? I will see you guys tomorrow.